Okay guys, so in this video what we're going to do is we're going to kind of start talking about 2.1, which talks about describing location of specific data points or data values that we have. The first way that we can look at, the reason why we do that is like just to get an idea, like having a score of 78, it's just a score of 78 out of 100, but it doesn't give us an idea of like who we are compared to other people. And a lot of times you guys get, like when you take the SAT or any type of standardized test, you guys get a score, but then you guys also kind of have the allocation of where you are compared to everybody else. And what that represents is something called the percentile. And so the percentile of a distribution is the value with P observations less than you. Okay, so P percent of the observations that are less than or equal to it. So like an example, if I look at 86, Jenny earned an 86 on her test. How did she perform relative to the rest? Well, first we got to find out where 86 is. 86 is right here, okay? So from there, and then we know how many students are there. Well, I think there were 24 people in this set of data, okay? Well, or I guess it was 25. There were 25 pieces of data, and if I look at Jenny, Jenny ended up being the 22nd person out of this whole set. So if I take 22 out of 25, that's going to get me the fact that she's the 88th percentile in regards to her class. So let's look at this set of data. What I want to do is I want to try to find, given I know that there are 30 teams in the Major League as of 2016, which I think there still are, I want to find the percentile rank for the Detroit Tigers. So what I want to do is I want to identify where 86 is. Okay? 86 is right here. Now, but Mr. Graham, there's like 3 values that go with 86. We're going to go with that last one. Okay? So if I count 59 all the way to 86, I know that that represents the 20th team. So what I'm going to do with that 20th team then is I'm going to take 20 and divide it by the total number. Now it's going to be approximately 0.67. It's like 0.666667 or whatever. And from there, I can make a conclusion. Like that's 0.66 or 0.67 is the same thing as 67%, which then gives me the fact that it's the 67th percentile. Okay? Which then gives me the final conclusion that I can say that the Detroit Tigers wins are the 67th percentile of all Major League teams, which is pretty good when you look at that overall. Now, let's look at the Cleveland Indians, or, well, that was what they were back then, or the Clark Guardians now. Like, let's look at the number of wins. We know that the Cleveland Indians were at the 90th percentile of the distribution. And then we're going to try to interpret in the value of the context. So what I'm going to do is if I know it's the 90th percentile, I'm going to take 0.9, because that's the same thing as like the decimal form of 90th percentile, and I'm going to multiply it by 30. So what I'm going to be doing is I'm going to be looking for that 27th team in this list or the stem plot. Okay? So when I do that, I kind of identify the 27th number to be approximately 94. So the Guardians were the 27th team, okay? So the 27th team aligns with 94 wins, okay? So the Indians had 94 wins in 2016, okay? Now, what I can do is I can take all these percentiles and I can create something called a cumulative relative frequency plot, okay? It's just one way for me to visualize what's going on. So like in this set of data, we're looking at the ages of 44 presidents when they were inaugurated. So like in between the range of 40 to 44, there were 2. Between the range of 65 to 69, there were 3 presidents that had that. First thing that we're going to do is just find out what their relative frequency is. Like what percent had that range. Like if I look at 50 to 54, I know that 29.5% of the presidents that were inaugurated fell within this range at the age when they were inaugurated. Now from there, what I'm really trying to do is find their cumulative frequency. So what the cumulative frequency is, it's me taking like 2 plus 7 to get me 9. if I take 9 plus 13, that's going to get me 22, and so on and so forth. So like if I look at 50 to 54, like I know that 22 presidents are lower, or like at or lower that range of age. So like 22 fall at or below 50 to 54. Okay. Now that number, I mean, we can look at that and work with it, but we can mostly use it for percentile rank. Okay, cumulative relative frequency. So what that means is that if I look at the age 50 to 54, it looks like 50%, okay, 50% of the president's inauguration age was below or at or below 50 to 54, okay? And then I can say that 50% are above that in the range, between 55 to 99 or 69. Like 50% of the people fall within that category. So let's just look at an example, okay? So in this case, what we're trying to find is this data represents the median ages of all 50 states, or median household incomes for all 50 states, including District of Columbia. Okay? The first question that we're trying to find is what is the percentile rank for California that had a median age of 57,445? So in order for me to help find out what that percentile rank is, first I want to kind of identify where 57,445 would be on this horizontal axis of median incomes. So I'm just going to kind of draw a little line or a box, like I'm estimating that 57 is about here. It's like in between 55 to 60, okay? So 57 is in between 55 to 60. I'm going to go vertically straight up and then straight across, and what I will find is that $57,445 is about equivalent to the 80th percentile, okay? This value on the vertical axis is kind of telling me what that percentile rank is going to be. So California, 80th percentile is the location of median household value of 57,445 for California. Now, the next one's asking us to identify what the first quartile is. And if you guys remember, that is the same thing as the 25th percentile. Okay? So what I'm going to look at first is I'm going to look at the vertical axis, okay, and try to identify where about is 25%. And I'm going to just estimate right there. And just like I did before, I'm going to make a box with that. Okay, so I'm going to go straight across to where it hits the graph, and then I'm going to go straight down. So it looks like it's going to be approximately $45,000 is the median income. So I would say that the 25th percentile of median house income is approximately $45,000. Okay? Now, what I'm going to ask you guys to do is, if on the next page of notes, I'm going to ask you guys to try to do these check for understandings. We'll talk about them the next day that I see you. But just try those out, and we'll talk through that a little bit more. Okay? Now, the next thing, another way that we can kind of describe location is using something called a z-score. Okay? And a z-score tells us how many standard deviations from the mean an observation falls. Okay? So it could be great, or it could be above, or it could be below. All right? So in this case, when we want to find z-score, what we will do is we will take whatever our value is and subtract our mean, and then divide it by the standard deviation. And this is going to be a formula that we're going to use a lot over the whole semester or whole year. So just keep this one in mind, okay? So just to give you guys an example, like looking back at Jenny scored an 86 on her test. The class mean was 80, and the standard deviation was 6.07. So we just took 86 minus 80 and divided it by 6.07. We got a z-score, this is what her z-score turns out to be, of 0.99. So what that means is Jenny's test score is 0.99 standard deviations greater than the class mean of 980. Okay? So one thing just to keep in mind is it always indicates if the value is greater than or less than the mean. That's what z-score always tells us. It's not how away from the mean it is. So let's just look at this situation. And we're going to be looking at Chicago Cubs, and we're going to look at the Chicago White Sox. When I look at this statement, it's telling me that my mean, and I'm going to just write it symbolically, the mean is 81, and my standard deviation is 10.7. And I'm going to use these two pieces of information to help me find the z-score for the Chicago Cubs. Okay, so once again, we said that x bar is 81, and then my standard deviation is 10.7. So what I'm going to do is I know that Chicago Cubs had 103 wins in 2016. Regrettably, they had 103 wins in 2016. So what I'm going to do is I'm going to take that value of 103, I'm going to subtract 81, and then I'm going to divide it by 10.7. And that's going to be what my z-score is. So with my handy-dandy calculator, I'm going to take 103 minus 81, and I do know that that's going to be 22 over 10.7. And I get a z-score of 2.056. So what I can say is that the Chicago Cubs number of wins is 2.056 standard deviations above the mean of 103 wins. Okay? Now, just looking at one other situation, in Part B, what we were asked to do is, like, I'm told what the z-score is, so I do know what my z-score is. It's negative 0.28. And what I'm trying to do is find out what the value is. So what I'm going to do is I know that it's going to be negative 0.28. I do not know what this value is, so I'm just going to put x there, minus the mean of 81 divided by 10.7. Now, this is probably some of the more amounts of algebra that we're going to do here in this class. Not too complicated, just solving this linear equation. I'm going to multiply both sides by 10.7. And so if I take 10.7 times negative 0.28, I got negative 2.996, which is x minus 81. And I'm just going to add 81 to both sides. And I get x to be about 78 wins. So it appears that the Chicago White Sox won 78 games. Okay? So what I'm going to ask you guys to try to do for me is just with this next, at the bottom of this page, just try page 97, checks 1 and 2, and we'll talk about those next day I see you. Have a great weekend.